I'm going to build on what Anache said.
You have another weight to add onto hers.
And is 2/10 equal to 15/100 or not equal to?
Nice.
How do you know?
If you put a line right there, then it would equal 2/10.
You can help out the person who's doing the problem and not be rude.
I disagree with Dad's right.
We did it a different way.
The teen was right. Yeah, she got it okay.
No more pitfalls.
Now let's watch a Math Pathways and Pitfalls lesson in action. Look for ways the students help each other understand the math.
Here's day 1.
So, boys and girls, we're going to start this morning by reviewing our discussion builders. I'd like you to take a look up at the chart, please.
Building on others' idea. I have a question about Blank's idea. I understand Blank's idea, but what about? I'm confused about. I'd like to add to Blank's idea. I agree with Blank's idea because.
Would that be true is there another way? Can we think of a counter example?
I'm going to ask you to make sure to use these discussion builders today, and I want you to especially focus on the last one.
How could we prove it?
And I'd like you to ask people who come to the front, if you feel like they haven't proven their idea, I'd like you to say, how could we prove that? Okay? Let's go ahead and read the purpose of today's discussion. Can I get a volunteer, please? Angel.
Find equivalent decimals for fraction amounts.
Thank you. Now we're going to go over some math words that will be important in our discussion today. And what I'd like you to do is, as I say them, I'd like you to say them to yourself quietly. Okay? Decimal amounts are in tenths, hundredths, and thousandths. I want you to think of an example. An example I'm thinking of is, for example, 4/10ths, or 45 hundredths, 360 thousandths. Decimal point. Whole numbers are to the left of a decimal point, and parts of the whole are to the right. And let's think of the example 3 and 5/10ths. There's 3 wholes, and then 5/10ths of the whole. Okay? We're going to go ahead and do a starter problem now. And again, I'd like you to read this quietly in your mind as I read it out loud. 1/5 of this rectangle is shaded. What decimal amount is shaded? I'd like you to work on this problem on your own. And as you work on it, I want you to think, where might somebody make a pitfall? Take about another minute to finish working on your own. Please remember to think about where somebody might make a pitfall. You might have a pitfall if your answer to this question has the digits 1 and 5. But that's okay, because that's why we're going to do this discussion. We're going to learn about that pitfall. It says okay next to Lee's work, and let's read what he said. I needed a decimal, so I called the whole rectangle 10/10ths. There are 10/10ths in all, so each of the 5 parts has 2/10ths. I could have called the rectangle 100 hundredths, or 1,000 thousandths too. On your own, I'd like you to try and figure out why Lee said that since he needed a decimal amount, he called the whole rectangle 10/10ths. Please share what you've written and drawn and talk about why would Lee say that that whole rectangle is 10/10ths?
It was 10/10 because when you make a decimal, you need to have like tens, thousands, hundreds.
¿Cuántas veces la una? Esto, 10. ¿Es una media? No, son 10 dividido entre 10.
You could color two. That's a kind of pitfall. This one is not a pitfall because I color two, but 2/10, and that's equivalent to this one.
I agree.
Now we're going to go ahead and use our discussion builders to talk about Lee's ideas. And I need a volunteer who would like to come up here and share their thinking about Lee's work. Leslie.
I agree with Lee's idea because I think he already knew that you can't write 1/5 as a decimal, so he had to split them into tenths. And if this is 1/5 and it's not in tenths, he decided to split each fifth into 2/10. And the 1/5 he shaded in is 2/10.
Could you explain why he wrote 10/10 or 1/2 above that diagram?
Because each fifth he split it into 2/10 became in the whole rectangle as 10/10 in total.
Would somebody like to respond to that? Angel.
I agree that she said 10/10, or like how she here 10/10, 100 hundreds, or 1,000 is equivalent to a whole. So he could have put like 20 hundreds or 2/10 or 200,000s.
I'd like you to take a look at your paper and look at what Lee said. I'd like you to think about what Lee meant when he said, I could have called the rectangle 100 hundredths or 1,000 thousandths. Angel discussed that up here. But I would like you to talk to your neighbor about what did Lee mean when he said that, and could you come up with any diagrams that prove that?
We had tenths, and that would be 2/10. But now we divide it in hundreds, and then it's 20 hundreds. And if we divide this in thousands, it would be 200,000. So like it's the same thing. You just keep adding zeros and like more little squares.
Also, if you drew tenths right here, like there's 10/10, and then the 1/5 is shaded, and then I did hundreds, and then I shaded 20 hundreds, and it was equivalent 2/10 with 20 hundreds, and then I think it will be the same thing with thousands and 10,000s.
And I could have done 1,000, but that's a lot of squares, so I just did 100. I did 100. I colored it in, and it equals 1/2. And this I color it in, and it equals 1/2. They're all the same.
I'm wondering if somebody could come up and show us what 100 hundredths would look like. Jose.
Like me and Eileen were discussing that we could just like draw a diagram in tenths, then divide it in hundreds, and then we could shade in two of them. That would be 2/10, but we don't have to make another diagram because you could just add in hundreds. It'll give you the same answer, except it'll be 20 hundredths. It don't make a difference, like Angel said right here.
I would like you to take a look at Maria's work. Maria said, how easy. 1/5 is the same as 0.15. You just put a decimal in front. Maria made a pitfall that lots of students make when they do a problem like this. What I'd like you to do now is I'd like you to share your ideas with your partner.
It's also incorrect because she just took the number from a fraction, and when you do a decimal, you have to put into tenths, hundreds, or thousands. And she just like put the number from a fraction, and those numbers were in tenths, hundreds, or thousands. Exactly.
How could you see if that's equivalent or not?
No, it's not 1/5 because it will be two tenths or 200.
And is 2/10 equal to 15 hundredths or not equal to?
Not equal to.
How do you know?
because Maria, she probably just said that you should put 1 right here, the 1 go like 1 point. She probably did that, but I disagree with her because she's supposed to like multiply this 2 by 2. You get 2 tenths, so it'll be 2 tenths.
Okay. So is there somebody who could come up here and show us how they know that 1/5 is not equal to 15/100ths? Evelyn?
This is 1500s. That's 2 tenths. So 2 tenths is bigger than 1500.
Angel?
I agree with Evelyn's idea because 2 tenths is 20/100s, and 20/100s is 5 units away from 1500s.
Thank you. Monica?
I agree with Evelyn because it's not true that 1/5 equals to 1500ths. Because I was telling my partner that maybe Maria thought that the line could be the point.
What do you mean that Maria thought the line could be the point? Could you show us that?
Like Maria thought that 1/5 equals to 1500ths. So I thought that maybe she thought that this line would equal to the point.
And so would that be correct or incorrect to think that that's the point?
Because sometimes the line is the it told us that it's also the division line.
Okay. Would you label that as a pitfall so we don't get confused? Thanks, Monica. What I'm going to ask you to think about now is, what do we need to remember so that we don't make pitfalls like this? I'd like you to discuss with your partner for a moment what you think is important to remember, and then I'm going to take some of your ideas.
To compare that drawing with the other drawing, like we found out that 1/5 is equal to 2 tenths. You shouldn't think the line should be a decimal point. When you do multiplication and pictures, you can give examples like what's this and what I'm doing.
All right, boys and girls, I'm going to ask for a quiet hand for somebody who would like to share something you think we need to remember so that we don't make pitfalls like this in the future. Eileen.
I think that you should remember that when you're turning a fraction into a decimal, to turn the denominator into tens, hundreds, or thousands.
Thank you, Eileen. Roberto?
Another thing we should remember is not like to confuse the fraction line into the decimal point.
Thank you, Roberto. And Iris.
I think we should remember to draw a diagram to see so you could imagine like how it would look like to draw a diagram.
And I'm going to push you a little bit. What would you want to imagine in each part of your diagram? What would you want to put on the diagram?
Like the fraction, like in a decimal, make the fraction to a decimal and try to imagine where they go.
Okay. So let me clarify if I have that right. So draw a diagram, and for each part, write the fraction in a decimal form. Is that what you meant? Okay. All right. Thank you very much. I'd like you to go ahead and add the things to remember to your paper so that you'll be able to remember that for tomorrow's discussion. Let's take a few minutes to reflect on our discussion builders. So somebody who'd like to share a discussion builder that was used during today's discussion and how it helped us discuss the math? Edgar.
I want to add to Blank's idea, and it helps us because it makes the discussion stronger.
Why? Why does it make the discussion stronger?
Because it's lots of people worked on that.
Thank you. Monica.
And the one that I agree with Blank's idea because it helped us because if you disagree, maybe somebody could be right or wrong. If you say every time that you agree, maybe you will find the right answer. And how could we prove it? Because every time when people talk, some people ask, how could you prove it? Like to make sure that they were right.
First, we review our discussion from yesterday.
I'd like you to look over page 1 and see if you can remember what we talked about during yesterday's discussion. Could I get a volunteer to explain what did Maria do that was a pitfall? Jose?
She just guessed and put 1/5 together and put a decimal point in front.
Okay, thank you very much. What I'd like you to do next is I'd like you to review our things to remember. You can either read the chart or you can read things to remember on your own paper. I want you to read each item very carefully. Take a minute to do that, please.
Now it's time for our turn.
What I'd like you to do now, please, is turn to page 2, where it says decimals or fractions too, and it says our turn. I'd like you to look at the first problem, please. 4/5 is equal to, I'm going to ask you to write a decimal name in tenths or hundredths for that shaded part. Please do only number 1, and I'd like you to work together with your partner on this.
And if you multiply, let's multiply 4 first. So it's 4/5 times 2 equals 8/10.
Multiply by 2, or cut it like that, and it will equal 8/10 or 0.8 or 8/10.
So I'm going to ask for a volunteer to come up and share with us what decimal amount is equal to 4/5. What did you and your partner discuss? How did you figure out what's a reasonable answer? Edgar, would you come up, please?
We thought that it was 8/10 because in decimal you have to make it into tenths, hundreds, or thousands, and so you had to make this into tenths. So we just did each one. We divided by 2. It's kind of cut into 10th parts, so then it's 8/10. And also, you could do it by because 4 times 2 equals 8, and 5 times 2 equals 10, so it's 8/10.
Edgar, would you be able to label your diagram how much each piece is worth in a decimal amount? Okay, thank you. All right, I would like you now to look at the second problem. And I'd like you to go ahead and, again, work with your neighbor on the second problem, find a decimal amount, and I'd like to hear you talking as you're working. Okay? So it's now your turn to do some problems on your own. I would like you to remember everything we've discussed yesterday and this morning as you're doing these problems. And for every problem, keep in mind, what's a possible pitfall that I could make here?